G'day everyone, how are you going? Back here in Specialist, we're doing integration using substitutions. Now, essentially this part of the course should not be a difficult part. You know how to integrate, you know how to integrate between limits. We're just adding that substitution part in there because for some reason the way the formula is set up is too difficult to integrate or we can't see where we're going with it. So an example is this one here, which has got, it's kind of quotient rule, and that's the first giveaway that maybe a substitution would be handy. It's quotient rule, it's got a square root in there. I really don't know what that's going to turn out like. But if I make a substitution, I think I can make it easier. The reason that I think I can make it easier, I notice this part under here. If I take the derivative of that, then I get 6t squared plus 1. Which is exactly what I've got on the top line. So for that reason, I'm thinking a substitution will work. I'm going to let u equal this thing underneath here, and that means I can then work out du dt, because this is u in terms of t. So let me work that out. What do we got? We've got 6t squared plus 1, which as I thought was the derivative up here. Now then what I'm going to do, I've constructed some of this here. This is the same question as that. But instead of writing this here, I've written just u, haven't I? Alright? And instead of writing just dt, I've still got dt in there, but I've added du top and bottom line. Now they're going to cancel out. Or they kind of effectively cancel out, but I'm not going to because I want them in there. Now I've just worked out du dt. So therefore dt du is exactly the other way. So what I'm going to end up with is dt du equaling 1 over this thing, 6t squared plus 1. Now I'm going to substitute that in there, and if I take that and substitute it in there for that, can you see how this bit on the bottom line that would sit here is going to cancel with this bit here? That would be on the top line. I would have 6t squared plus 1 there. And this one will replace that, meaning that the 6t squared plus 1 on the bottom, 6t squared plus 1 on the top will cancel. And that's the whole reason I did this substitution. So what have we got now? Well, I've got 1 on the top line, square root of u on the bottom line, du. So I've got 1 square root of u du. But I'm not finished with my substitution because these limits here, these limits were all in terms of t. But my question's no longer in terms of t. Now I've got it in terms of u. So I've got to change my limits to be in terms of u. So what do? I take that limit, here we go, if t equals 0, u equals, well 0 is going to go into here. So that's going to be 0, 0 plus 1, that's going to be 1. Take the 10, put it in here, cubed, 1,000, 2,000, 2010, 2011. Whoops. Right? So those limits now are going to go here, 1 and 2011. Big number, crazy number, don't worry about that. This now I can integrate. So I might tidy this up a little bit. Instead of using the square root sign, I'm going to change that to a half. And actually I'm going to change it a little bit more because I'm going to bring it to the top line and write integral of u to the negative a half du between 1 and 2011. Now that's not so bad to integrate because raise the power by 1, divide by the new power, and divide by the derivative. Oh, actually, no, I don't even need that part. No, I don't even need that. What do we need to do? Raise the power by 1. Divide by the new power. Well, dividing by a half is the same as multiplying by 2, isn't it? So I don't need to worry about that. And then because I've now done my integration, square brackets, 1, 2011. Now, I'd probably jump to calculator now. I know this was a non-calc question, but we can throw it on in there, work a few things out, and we're away. What are the key takeaways here? Spot what the substitution is going to be. Got to be able to do that. Don't forget to change your limits and recognise that if you've done all this correctly, then things should cancel out and come out quite neatly. Okay? They're intended to come out neatly. If it starts getting crazy, you've probably made a mistake. Hope this video has helped on doing substitutions. Check the next video, which will be on using trig substitutions in these sort of questions. They're a little harder to spot. Hopefully this one's helped. Catch you later.